we're going to go over to this website, slickcharts.com, and you're going to see what's called the Magnificent Seven. Let me zoom in. So this is a website that goes over the US stock markets. So we've got the S&P 500, the NASDAQ 100, and the Dow Jones over here. There's a few other ones that they go over. And there's a group called the Magnificent Seven. All right. And this is going to be critical to a later article we're going to go over. So let's click on Magnificent Seven. And what's this? Does anybody recognize these companies? Who is the Magnificent Seven? We have Amazon, Apple, Google, Meta, Microsoft, nvidia, and OpenAI. And then over here, Magnificent Seven, we have nvidia, Microsoft, Apple, Amazon, Google, Meta, and Tesla. So 5 out of the companies listed in here are part of the Magnificent Seven. What is the Magnificent Seven? Well, we'll get to that. We'll get to that. That's important. But now let's go over to this article. NVIDIA is full of shit. And not just regular shit. Now, it's not just like rabbit-sized pellet shit. We're talking like elephant-sized shit, where it's like half a human body. All right? So keep in mind that NVIDIA is part of the Magnificent Seven right here, okay? And keep in mind that NVIDIA is heavily tied to these companies, including themselves pushing for the certification of these AI systems. And I want you to keep in mind the question of why these companies continue to push billions upon billions of dollars into all of these kinds of things, including making it more accessible to education companies. All right. So this Magnificent Seven, 5 out of the 7 companies are listed here, etc., etc. And let's get into NVIDIA is full of elephant shit. This is from a website called Sabins. Since the disastrous launch of the RTX 50 series, NVIDIA has been unable to escape negative headlines. Scalper bots are snatching GPUs away from consumers before official sales even begin. Power connectors continue to melt. Yes, with no fix in sight. Marketing is becoming increasingly deceptive. GPUs are missing processing units when they leave the factory, and the drivers, for which NVIDIA has always been praised, are currently falling apart. And to top it all off, NVIDIA is becoming increasingly insistent that media push is a certain narrative when reporting on their hardest. I want to point this out. Okay. All right. What's an MSRP? Just like with every other GPU launch in recent memory, this one has also been ripe with scalper bots snatching up stock before any real person could get any for themselves. Retailers have reported that they've received very little stock to begin with. This in turn sparked rumors about NVIDIA purposefully keeping stock low to make it look like the cards are in high demand to drive prices. And sure enough, on secondary markets, the cards go way above MSRP. And MSRP stands for Manufacturer Suggested Retail Price, by the way. And some retailers have started to bundle the cards with other inventory, PSUs, monitors, keyboards, and mice to inflate the price even further and get rid of stuff in their warehouse people wouldn't buy otherwise. And you don't even get a working computer out of spending over twice as much as a GPU alone would cost you. Have a look at this Newegg. Here is a Newegg RTX 5090 32 gig GDDR7 OC edition PCI Express 5 with DLSS 4 at the cheap chump change pocket change cost of $3,359.99, and I believe this is US. How about this one? The Asus ROG Astral GeForce RTX 5090 032G OC gaming graphic card sofort lieferbar. Euros, 3,349.95. What's up, Nuke? What's up, D-Daver? Good to see you guys. Thanks for being here. I appreciate it. Welcome in, everybody. All right. I had a look at GPU prices for previous generation models for both AMD and NVIDIA as recently as May 2025, and I wasn't surprised to find even RTX 40 series are still very much overpriced. With the GeForce RTX 4070 lower mid-tier starting at $800, MSRP $599, whereas the same money can get you a Radeon RX 7900 XT, the second best GPU in AMD's last generation lineup. The discrepancy in bang for buck couldn't be more jarring, and that's before considering that NVIDIA gave out defective chips to board partners that were missing ROPs, raster operations pipelines, from the factory, thus reducing their performance, or how NVIDIA put it in a statement to The Verge. We have identified a rare issue affecting less than 0.5% of GeForce RTX 5090, 5090D, and 5070 Ti GPUs, which have one fewer ROP than specified. The average graphical performance impact is 4%, with no impact on AI and compute workloads. Affected consumers can contact the board manufacturer for a replacement. The production anomaly has been corrected. Those 4% can make an RTX 5070 Ti perform at the levels of an RTX 4070 Ti Super Cyan, completely eradicating the reason you'd get an RTX 5070 Ti in the first place, not to mention that the generational performance uplift over the RTX 40 series was already received quite poorly in general. NVIDIA also had to later amend their statement to The Verge and admit the RTX 5080 was also missing ROPs. It's adding insult to injury with the card's general unobtainium, and it becomes even more ridiculous when you compare NVIDIA to another trillion-dollar company that is also in the business of selling hardware to consumers, Apple. How is it that one can supply customers with enough stock on launch consistently for decades and the other can't? The only reason I can think of is that NVIDIA just doesn't care. They're making the big bucks with data center GPUs now, selling the shovels that drive the AI bullshit gold rush to the point that selling to consumers is increasingly becoming a rounding error on their balance sheets. Could this be true? This article, the author of this article who made this point, couldn't actually be more right. I don't think even they realize how right they are with this statement. And we're going to get into exactly how and how this ties into the entirety of the US stock market being held hostage. Let's continue. These cards are fire and not the good kind. The RTX 50 series are the second generation of NVIDIA cards to use the 12VH PWR connector. The RTX 40 series became infamous as the GPU series with melting power connector. So did they fix that? No. The cables can still melt, both on the GPU and the PSU. It's a design flaw in the board of the GPU itself, which cannot be fixed unless the circuitry of the cards is replaced with a new design. Bros, I can't. With the RTX 30 cards, each power input, the cables from the power supply, had its own shunt resistor. If one pin in a power input had not been connected properly, another pin would have had to take over in its stead. If both pins were not carrying any current, there would have been no phase to the shunt on the shunt resistor and the card would not have started up. You get a black screen, but the hardware would still be fine. There is a video. I do not have permission to play the video. I know I could probably play it and it would be fine, but out of respect for other content creators, I don't like to play their videos unless I have their permission to do so. Other people put work in just like I do, so I'm not going to go over the video. It is on this article. If you want to find the link to it, it's going to be on my enlightenedprogramming.com website, or somebody can grab the link from me, whatever. You can search for it and you can watch the video yourself, all right? NVIDIA, in its infinite wisdom, changed this design starting with the RTX 40 series. Instead of individual shunt resistors for each power input, the shunt resistors are now connected in parallel to all pins of the power input from a single 12VH power connector. Additionally, the lines are recombined behind the resistors. This mind-boggling design flaw makes it impossible for the card to detect if pins are unevenly loaded, since as much as the card is concerned, everything comes in through the same single line. In other words, their restructure made it so that it was actually a lot harder to determine when you had to evenly distribute the load of power across pins. So the card is actually having a harder time figuring out when it's powered or not powered and whether it should run or not run and blah, 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 blah. Connecting the shunt resistors in parallel also makes them pretty much useless, since if one fails, the other will still have a phase, right? Power input connection, essentially, and the card will happily keep drawing power and not be any the wiser. If the card is supplied with 100 watts on each pin and 5 of the 6 pins don't supply a current, then a single pin has to supply the entire 600 watts the card demands. No wire is designed for this amount of power draw. That would be a miraculous outcome of power wires. As a result, excessive friction occurs from too many electrons traveling through the cable all at once, and it melts. NVIDIA realized that the design around the shunt resistors in the RTX 40 series was kind of stupid, so they revised it by eliminating the redundant shunt resistor, but changing nothing else about the flawed design. You know what I think is happening? I think what's happening is that NVIDIA is vibe coding their own power design. Yeah, they're using AI to ask it, how should we restructure our own power design? That's what's happening. They're using their own cards and they're going like, hey, we have a problem with these pins. AI, can you tell us how to fix it? And AI's like, I got you, bro. Just remove the redundant shunt resistor. It's easy, bro. And so here we go. We have another video. Again, I don't have permission, right? I haven't asked for permission to play it, so I'm not going to play it, but you guys can absolutely go look it up. There's something to be said about the fact NVIDIA introduced the 12VH power connector to the ATX standard to allow for only a single connector to supply their cards with up to 600 watts of power, but making it way less safe to operate at these loads. Worse yet, NVIDIA says the 4 sensing pins on top of the load-bearing 12 pins are supposed to prevent the GPU from pulling too much power. The fact of the matter is, however, that these sensing pins only tell the GPU how much it's allowed to pull when the system turns on, but they do not continuously monitor the power draw after that. That would be the shunt resistor's job, which NVIDIA kept taking out. If I had to guess, NVIDIA must be very confident that the sensing pins are a suitable substitution for those shunt resistors in theory, but practice showed they were not at all accounting for user error. That was their main excuse after it blew up in their face and they investigated. And indeed, if the 12VH power connector isn't properly inserted, pins could not make proper contact, causing the remaining wires to carry more load. This is something that the sensing pins cannot detect, despite their name, and NVIDIA selling it as some sort of safety measure. All right. This is the size comparison, by the way, between the 5090 FE on the right and its predecessor, the 4090 FE on the left. Check that out. It's at least twice the size. At least double. Okay. I mean, we're talking like you've gone from like you've gone from like a C cup to an A cup here. All right. NVIDIA also clearly did not factor in the computer cases on the market that people would pair these cards with. The 4090 was massive. It was a chonker. It was a heckin' chonker. Okay? It was so huge, in fact, that it kicked off the trend of needing support brackets to keep the GPU from sagging and straining the PCI slot. It also had its power connector sticking out to the side of the card, and computer cases were not providing enough clearance to not bend the plug. As was clarified after the first reports of molten cables, bending a 12VH power cable with at least 35 mm or 1.38-inch clearance could loosen the connection with the pins and create the problem of melting cables, something that wasn't a problem with the battle-tested 6 and 8-pin PCIe connectors we've been using up to this point. Board partners like ACES try to work around that design flaw by introducing intermediate shunt resistors for each individual load-bearing pin before the ones according to NVIDIA's designs, but these don't solve the underlying issue that the card won't shut itself down if any of the lines aren't drawing enough or any power. What you get at most is an indicator LED blinking light and some software telling you, hey, everything seems off. Maybe take a look. Just maybe take a look. The fact NVIDIA insists on keeping the 12VH power connector around and not do jack shit about the design flaws in their cards to prevent it from destroying itself from the slightest misuse would deter you from considering any card from them that uses it. Over the years, NVIDIA has released a number of proprietary technologies to market that only work on their hardware. DLSS, CUDA, NVENC, and G-Sync, to name a few. The tight coupling with NVIDIA's hardware guarantees compatibility and performance. So this is very true. You can even see this right now. There are certain features with video games that, like when you're playing a game and you want to tweak the graphics setting, DLSS would be one, CUDA would be another, G-Sync definitely another one, but you can only get these if you have an NVIDIA card, right? However, this comes at considerable price these days, as mentioned earlier. If you're thinking about an upgrade, you're either looking at a down payment on a house or an uprooting of your entire hardware and software stack if you switch vendors. If you're a creator, CUDA and NVENC are pretty much indispensable, or editing and exporting videos in Adobe Premiere or DaVinci Resolve will take you a lot longer. Same for live streaming, as using NVENC and OBS offloads video rendering to the GPU for smooth frame rates while streaming high-quality video. Speaking of games, G-Sync in gaming monitors also requires a lock-in with NVIDIA hardware, both on the GPU side and the monitor itself. Yes, by the way, the monitor itself, in order to get G-Sync, actually requires an NVIDIA processing chip inside of the monitor, at least in some monitors. Yeah, there we go. I pre-read. G-Sync monitors have a special chip inside that NVIDIA GPUs can talk to in order to align frame timings. This chip is expensive and monitor manufacturers have to get certified by NVIDIA. Therefore, monitor manufacturers charge a premium for such monitors. The competing open standard is FreeSync. I'm sure you've heard of this, spearheaded by AMD. Since 2019, NVIDIA also supports FreeSync, but under their G-Sync compatible branding. Personally, I wouldn't bother with G-Sync when a competing open standard exists and differences are negligible. And there's a link. He provides references to all of these things. And so there's another video, and so let's keep going. The PC as a gaming platform has long been held in high regards for its backwards compatibility. With the RTX 50 series, NVIDIA broke that going forward. PhysX, which NVIDIA introduced into their GPU lineup with the acquisition of AGEA in 2008, is a technology that allows a game to calculate game world physics on an NVIDIA GPU. After the launch of the RTX 50 series card, it was revealed that they lack support for the 32-bit variant of the tech. This causes games like Mirror's Edge and Borderlands 2 that still run on today's computers to take ungodly dips into single-digit frame rates because the physics calculations are forcibly performed on the CPU instead of the GPU. Even though the first 64-bit consumer CPUs hit the market as early as 2003, think AMD Opteron and Athlon 64, I remember building these, 32-bit games were still very common around these times, as Microsoft would not release a 64-bit version of Windows to consumers until Vista in 2006. NVIDIA later released the source code for the GPU simulation kernel on GitHub. The pessimist in me thinks they did this because they can't be bothered to maintain this themselves and offload that maintenance burden to the public. DLSS is, and always was, snake oil. Back in 2018, when the RTX 20 series launched as the first GPUs with hardware-accelerated ray tracing, it sure was impressive and novel to have this tech in consumer graphics cards. However, NVIDIA also introduced upscaling tech alongside it to counterbalance the insane computational expense it produced. From the beginning, the two were closely interlinked. If you wanted ray tracing in Cyberpunk 2077, the only game at the time that really made use of the tech, you also had to enable upscaling if you didn't want your gameplay experience to become a ridiculously pretty PowerPoint slideshow. That upscaling tech is now what we call DLSS, or Deep Learning Super Sampling. It renders a game at a lower resolution internally and then upscales it to the target resolution with specialized accelerator chips on the GPU die. The only issue back then was that because the tech was so new, barely any game made use of it. What always rubbed me the wrong way about how DLSS was marketed is that it wasn't only for less powerful GPUs in NVIDIA's lineup. No, it was marketed for the top of the line, $1,000 plus a pop RTX 20 series flagship models to achieve the graphical fidelity with all the bells and whistles. That to me was a warning sign that maybe, just maybe, ray tracing was introduced prematurely and half-baked. Back then, I theorized that by tightly coupling this sort of upscaling tech to high-end cards and ray-traced graphics, it sets a bad precedent. The kind of graphics NVIDIA was selling us on was beyond the card's actual capabilities. Needing to upscale to keep frame rates smooth already seemed fake to me. If that amount of money for a single PC component still can't produce those graphics without using software trickery to achieve acceptable frame rates, then what am I spending that money on to begin with? Exactly. Fast forward today, nothing's changed. Besides NVIDIA now changing Now charging double the amount for the flagship RTX 5090. And guess what? Guess what? Do you think it does Cyberpunk 2077, the flagship ray tracing game with full ray tracing at a playable frame rate in native 4K, only with DLSS enabled? Yes, that's right. That's right. There is actually no actual hardware improvement to make DLSS ray tracing run properly on your GPU. No, in fact, it still defaults to your CPU. That's right. That's right. And what are you paying for it? Your future children's inheritance money. That's what you're paying for it. From the RTX 4090 website, we've gone over, I believe we went over a similar one where AI was touting its own, 5070 cards. There was an entire video we did on that. We covered it already. And then the 5090 website. Again, I won't show these. I won't play these videos. You guys can go check them out. But this one in particular is part of the AI generated, where it doesn't just upscale on your CPU. Apparently, it doesn't just upscale. No. What it does is it uses AI to determine the frames that should exist between frames. So if you're actually running at 30 frames a second, but you want to hit the sweet 60 FPS spot, it'll use AI and DLSS with ray tracing all turned on, all of that stuff turned on, so that it can determine what should exist between frames to give you the feeling of 60 FPS. In other words, they have no idea how to build a proper GPU card anymore. And instead, they're just going to offload all of their GPU card capabilities, their hardware capabilities, to AI. So here we go. 4K native RT overdrive FPS. The MSRP of the 4090, $1599 for about 20 frames per second. The 5090, a sweet extra 7 frames per second. And what are you paying for? $400 more. So 7 years into ray traced real-time computer graphics, and we're still nowhere near 4K gaming at 60 FPS, even at $2,000. Sure, you could argue, turn ray tracing off and performance improves, but then why did you spend all that money? Pure generational uplift in performance of the hardware itself is minuscule. They're selling us a solution to a problem they themselves introduced and co-opted every developer to include the tech into their games. Yes, that's right. Now you can kind of see how this ties into the programming stuff we talk about. These kinds of things are now impacting the very way games are made, which includes the code you create to run a game. Based on what? Something that does not work. Now they're doing an even more computationally expensive version of ray tracing, path tracing. So all the generational improvements we could have had are nullified again, and I'm sure that they will increase their prices even more. And even if you didn't spend a lot of money on a GPU, what you get isn't going to be powerful enough to make those ray traced graphics pop and still run well. So most people's experiences with ray tracing is turn it on, see how it looks, realize it eats almost all your FPS, and never turn it on again, thinking ray tracing is a waste. So whatever benefits in realistic lighting was to be achieved is also nullified, because devs will still need to do lighting the old-fashioned way for the people who don't or can't use ray tracing. Making the use of upscaling tech a requirement at every GPU price point for every AAA game to achieve acceptable levels of performance gives the impression that the games were sold at targeting hardware that either don't exist yet or nobody can afford. We need constant band-aids to make it work. Pretty much all upscalers force TAA for anti-aliasing, and it makes the entire image on the screen look blurry as fuck the lower the resolution is. An example, Red Dead Redemption 2, showing TAA in action, your $1,000 at work. Again, I don't want to show this video without permission. Please go look this up. Or if you like Red Dead Redemption 2, go ahead and play this. All right? Frame generation exacerbates this problem further by adding to the ghosting of TAA, because it guesstimates where pixels will probably go in an AI-generated frame in between actually rendered frames, and when it's off, it really looks off. Both in tandem look like someone smeared your screen with Vaseline, and this is what they expect us to pay a premium for the hardware and the games. So now I just want you to take a minute and realize that the reason why games cost so much today is because they're being forced. They're being forced to operate this way. When you create a game, think about it from a programmer's perspective. You don't have to be a programmer, okay? To understand this, it's really, really simple. If you have a piece of hardware that is going to render your game in some kind of capacity, and that capacity comes with a serious design flaw that you can't work around, and you know that this hardware is going to get sold to consumers who may or may not turn this option off, what it means now is that you have to have two divergent paths in your code base. One code base has to account for the fact that some people will not operate the game in this way, and one code path will have to account for the fact that people do turn on these features in their hardware, which means now that the effort level is at maybe not doubled, but it's definitely increased. Guess what? More time, more money. Guess who pays for that? You do, which means you're getting screwed up two different holes in your body. Raw dog, no lube. You're getting screwed in the hardware end because the hardware vendor, in this case NVIDIA, is saying, pay us more money for effectively nothing. And then you're getting screwed again when you go and buy all of the games in your library suite, where you have to pay for the developers who have to account for this thing that ultimately, what does it do? Nothing. Most of you out here right now, I can see kind of a little bit in chat, are like, I hate TAA, I hate DLSS, I turn that shit off anyways. So what are you paying for? You're paying twice for nothing. Combine that with GPU prices being absolutely ridiculous in recent years, and it all takes the form of a scam, because that's what it is. That's what it is. It's a scam. As useful or impressive a technology as DLSS might be, game studios relying as heavily on it as they do, it's turning out to be detrimental to the visual quality of their games and incentivizes aiming for a level of graphical fidelity and complexity with diminishing returns. Games from 2025 don't look that dramatically different or better than games 10 years prior, yet they run way worse despite more modern and powerful hardware. Games these days demand such a high amount of compute that the use of upscaling tech like DLSS is becoming mandatory. The most egregious example of this being Monster Hunter Wilds, which states in its system requirements that it needs frame generation to run at acceptable levels. Have a look. Recommended specs, 60 FPS with frame generation enabled. So now we're getting into necessity. It is now being forced upon you. Meanwhile, Jensen Huang came up on stage during the keynote for the RTX 50 series cards and proudly proclaimed, RTX 5070 4090 performance at $549? Impossible. Impossible without artificial intelligence. What he meant by that, as it turns out, is the RTX 5070 only getting there with every trick DLSS has to offer, including new DLSS 4 multi-frame generation, only available on RTX 50 cards at the lowest quality setting, and all DLSS trickery turned up to the max. It's basically just bullshittery at its finest. You cannot tell me this is anywhere near acceptable levels of image quality for thousands of bucks. Again, go have a look at this. I believe I referenced this article when I went over the AI frame generated stuff from the announcement that NVIDIA did. I referenced it, but I didn't show it. Again, you're welcome to go look at it. This is absolutely banger. It was a very good one. Not only does that entail rendering games at a lower internal resolution, you also have to tell your GPU to pull 3 additional made-up frames out of its ass so NVIDIA can waltz around claiming runs insanely demanding came here at 5,000 FPS for the higher number equals better masturbator crowd. All the while, the image gets smeared to shit because NVIDIA just reinvented the motion smoothing option from your TV settings menu, but badly, and also it's AI now. Else, what would all these tensor cores be doing than waste space on the GPU die that could have gone to actual render units? Now, this leads directly into the next article that we're going to read, because this one's coming to a close, so I just want you to consider this. If it is true that NVIDIA does not give a shit about consumer-based hardware usage like video games now, then could it be possible that they actually give a shit about the AI stuff? And if that's true, wouldn't it make sense that they would reduce their production factor by focusing on all the AI stuff first and then making the video game stuff fit the mold, so to speak? That was a pun. It was intended. Yes, of course. And so how would they do that? They would first focus on the biggest moneymaker, which is just pure AI and data centers and all of that, ChatGPT and all of that. And then they would fit everything else around that, because video gamers don't make them billions upon billions upon billions upon billions upon billions upon billions of dollars. No, it's nowhere near as close as when you look at the AI costs that the Magnificent Seven are spreading across each other's backs, which we're going to get into. So now we start to get a sense of why this would be happening, why NVIDIA would be doing this. NVIDIA likes you to believe DLSS can create FPS out of thin air, and they're trying to prove it with dubious statistics, only disclosing in barely readable fine print that it's a deliberate chosen very small sample size, so the numbers look very impressive. If I go and pop this open, this is an article from PC Gamer, and they go over these statistics of how they actually got their impressive stats. Okay, so you can look this up. I don't think we need to. I think it's pretty obvious. If you're a gamer and you use any of this, it's really easy to tell. The resolution is fake. The frames are fake. So is the marketed performance. Never mind that frame generation introduces input lag that NVIDIA needs to counterbalance with their reflex technology. Input lag that NVIDIA needs to counterbalance with reflex tech. Lest what you see on your screen isn't actually where you think it is, because again, it's AI frame generation. That didn't originate from the game logic. It originated from a completely separate thing. It's a completely separate part of the GPU. There is no game logic that includes it. It's just trying to discern what it should be next. That's it. That's all it is. They create problems for themselves that they then create solutions for in an endless cycle of trying to keep up the smoke screen that these cards do more than they're actually equipped to do. So a 20% premium for a 10% uplift in performance has the faintest resemblance of justification. I was afraid DLSS would get used to fake improvements where there are barely any back then, and I feel nothing if not vindicated for how NVIDIA is playing it up while jacking up prices further and further with each generation. None of that is raw performance of their cards. This is downright deceitful bullshit. The intimidations will continue until morale improves. It gets worse. It gets worse. NVIDIA lying on their own presentations about the real performance of their cards is one thing. It's another thing entirely when they start bribing and threatening reviewers to steer the editorial content in NVIDIA's favor. In December 2020, hardware review channel Hardware Unboxed received an email from NVIDIA senior PR manager Brian Del Rizzo after they reviewed NVIDIA cards on pure rasterization performance without DLSS or ray tracing, saying that performance did not live up to their expectations. Here is the email. Hi, Steve. We have reached a critical junction in the adoption of ray tracing, and it has gained industry-wide support from top titles, developers, game engines, APIs, consoles, and GPUs. As you know, NVIDIA is all in for ray tracing. RT is important and core to the future of gaming, but it's only one part of our focused R&D efforts on revolutionizing video games and creating a better experience for gamers. This philosophy is also reflected in developing technologies such as DLSS, Reflex, and Broadcast that offer immense value to consumers who are purchasing a GPU. They don't get free GPUs, they work hard for their money, and they get to keep their GPUs for multiple years. Despite all this progress, your GPU reviews and recommendations continue to focus singularly on rasterization performance, and you have largely discounted all of the other technologies we offer to gamers. How dare you, sir? It is very clear from your community commentary that you do not see things the same way that we, gamers, and the rest of the industry do. You evil, evil man who wants to have performant GPUs in video games. How dare you call us out for not creating better GPUs? Our Founders Editions boards and other NVIDIA products are being allocated to media outlets that recognize the changing landscape of gaming and the features that are important to gamers and anyone buying a GPU today, be it for gaming, content creation, or studio and streaming. And other words, how dare you spit on our work? We worked hard to give you nothing for more money. So you know what we're going to do? We're going to put our money into people who like what we do. Okay? Because our fifis are hurt. Okay, I'm going to go back to my mama. Okay, I'm going to go talk to my mama. My mama's not happy with you. Okay, I'm going to take my money. I'm going to do a different sandbox. Shut the hell up. Hardware Unboxed should continue to work with our add-in card partners to secure GPUs to review. Of course, you will still have access to obtain pre-release drivers and press materials. That won't change. We are opening to revisiting this in the future should your editorial change. Hardware Unboxed was thus banned from receiving review samples of NVIDIA's Founder Edition cards. It didn't take long for NVIDIA to backpedal after the heavily publicized outcry blew up in their face, which makes it all the more surprising that a couple of years later, they're trying to pull this again with Gamer Nexus. Here's another video. As Steve Burke explains in the video, NVIDIA approached him from the angle that in order to still be given access to NVIDIA engineers for interviews and specials for their channel, Gamer Nexus needs to include multi-frame generation metrics into their benchmark charts during reviews. Let me tell you something. This is very much a "but my feelings though" thing, because when I talk to people about why you shouldn't use React, there are some people who, in a debate, in an argument against me, will literally go, "Oh, but look at how many React developers really care about the React work that they do." Yeah? That's fantastic. I don't give one single fuck. Not one. Not one fuck given to those front-end developers who continue shoving React bullshit down my throat, making websites worse, and essentially just cancerizing, metastasis, I don't know, whatever the hell that word is, that medical word, the entire industry. I don't care how hard you worked to just shitify the entire front-end of web. I don't give one shit. Not even a fuck. Not one fuck, not one shit. NVIDIA is operating this exact same way. We're going to take all our money and we're going to go home. We're going to take our soccer ball and go play with people who actually like what we do. You don't do anything and you charge everybody more, way more. Why should I care? Steve rightfully claims that this tactic of intimidating media by taking away access until they review NVIDIA cards in a way that agrees with the narrative NVIDIA wants to uphold tarnishes the legitimacy of every review of every NVIDIA card ever made, past and present. Oh, yeah, okay. Yeah, this is the React argument. Oh, but React has been around for a long time. Are you going to, you want to go back to assembly, bro? Bro, shut the fuck up. Seriously. It creates an environment of distrust that is not at all conductive when you're trying to be a tech reviewer right now. This also coincided with the launch of the RTX 5060, a supposedly more budget-friendly offering. Interestingly, NVIDIA did not provide reviewers with the necessary drivers to test the GPU prior to launch. Instead, the card and the drivers launched at the same time. All of those reviewers were off at Computex, a computer expo in Taipei, Taiwan. The only outlets that did get to talk about the card prior to release were cherry-picked by NVIDIA. And even then, it was merely previews of details NVIDIA allowed them to talk about, not independent reviews. Because if they would have been properly reviewed, they'd all come to the same conclusion. 8 gig of VRAM would make this $299 budget card age very poorly because that is not enough VRAM to last long in today's gaming landscape. But it probably doesn't matter because NVIDIA is so busy tarnishing the reputation of their drivers, releasing hotfix after hotfix. What is this article? From The Verge. NVIDIA GPU drivers are a mess. A series of new drivers and hotfixes keep introducing issues for NVIDIA GPU owners. When was this from? April 22nd, 2025. It only just continues. Yeah, shut up, Verge. I don't want a subscription, all right? I might use some of the generous money you guys have tipped, which I really appreciate, by the way, to pay a subscription to one of these, but it's got to be worth it. The Verge ain't worth it, bro. In an attempt to stop their cards, old and new, from crashing seemingly randomly when encountering certain combinations of games, DLSS, and multi-frame generation settings, users of older generation NVIDIA cards can simply roll back to a previous version of the driver to alleviate these issues, but RTX 50 series owners? Nope. Because older drivers don't make their shiny new cards go. NVIDIA won. We all lost. And so now this coalesces right back into how the entire tech industry operates. React, Rust, Vite, Next, Vue, NPM, Node, microservices, Agile, I don't know. There's so many different things that are it's all bullshit. All of it. Tech wins. The quick VC exit. make programmers, developers, and now hardware manufacturers. And I warned you, if you watched my streams 1.5 years ago, I motherfucking warned you that this shit, this kind of thinking, this brain rot thinking was going to infect hardwares. I did say that. I know I said that. I'll go back and dig it up if I fucking have to, okay? I told you it was going to infect hardware, and it is. It is right now. This is how the tech industry operates. And AI is the ultimate culmination of all the stupid tech industry decisions in the past 10 to 20 years, all put in this nice little black box called AI so that we can generate more of it in mass. Okay? Let's keep reading. With over 90% of the PC market running on NVIDIA tech, they're the clear winner of the GPU race. The losers? All of us. Ever since NVIDIA realized there is tons of more money to be made on everything that is not part of putting moving pixels on a screen, they've taken that opportunity head on. When the gold rush for crypto mining started, they were among the first to sell heavily price-inflated GPU-shaped novels to anybody with more money than brains. Do you guys remember that? Do you guys remember the crypto rush? There was a GPU shortage during the crypto rush. You guys remember with Bitcoin and all that? People were buying. I remember articles that I was reading at the time when they were saying like we might run out of GPUs. Like people might not be able to get their hands on it for a long time. This could completely flatline us. Same now with the AI gold rush. PC gamers were hung out to dry. NVIDIA knows we're stuck with them, and it's infuriating. They keep pulling their shenanigans, and they will keep doing it until someone cuts them down a couple of notches, but the only ones who could step up to the task won't do it. Why won't they do it? Oh, we're getting into it, boys. We're getting into it. AMD didn't even attempt at facing NVIDIA at the high-end segment of this generation, instead trying to compete on merely the value propositions for the mid-range. Intel is seemingly still on the fence if they really want to sell dedicated GPUs while shuffling their C-suite and generally being in disarray. Both of them could be compelling options when you're on a budget, if it just wasn't for the fact that NVIDIA has a long-standing habit of producing proprietary tech that only runs well on their hardware. Now, they've poisoned the well with convincing everybody that ray tracing is something every game needs, and games that incorporate it do so on an NVIDIA tech stack, which runs like shit on anything that is not NVIDIA. That is not a level playing field. When the way it's meant to be played slowly turns into the only way it doesn't run like ass, it creates a moat around NVIDIA that's obviously hard to compete with. Thank you for the follow just now. And gamers aren't concerned about this because at the end of the day, all they care about is the game that runs well and looks pretty. But I want you to consider this. The games imbued with such tech creates a vendor lock-in effect. It gives NVIDIA considerable leverage in terms of how games are made, which GPUs you consider buying to run these games, and how well they will eventually actually run in your system. So it's a feedback effect, right? It creates the hardware that makes you lock into hardware, which makes games lock into hardware, which makes you buy the hardware, which then gives NVIDIA more power to create more hardware lock-in, and the cycle continues forever and ever. Just like tech, when you buy into Agile, you're stuck in Agile. When you buy into AI, you're stuck in AI. All of it. It's all the same bullshit. It's all just packaged in different forms. If all games that include NVIDIA's tech are made in a way that make it so you have to reach for more expensive models, you can be sure that's a soft power move NVIDIA is going to pull. And I'm going to do you one better. How about programmers who need to depend on AI to solve problems in their code and then have to pay for the tokens? Do you think maybe that's a little bit of a lock-in? As we established, it looks like they're already doing that. Tests show that the lower-end graphics cards cannot and probably were never intended to perform well enough, even with DLSS, because in order to get anything out of DLSS, you need more VRAM, which means the lower-end cards don't have enough VRAM, so how are you going to get anything out of DLSS? So they're upselling you on more expensive models. They're like, hey, you want DLSS? You can't really pay for the lower-end cards, can you? Because otherwise you don't get the benefit. And there are some games that you're not going to be able to play if you purchase the lower-end cards. So you kind of have to pony up. All right. So they cut corners in ways that make it a no-brainer for you to spend more expensively. Then they use their dominance in the market to control the media, to make sure you keep giving them money and you keep or at the very least misinformed. And when you don't have to compete and don't have any improvements to sell either, in incentivized actual R&D, you do what every monopolist does and write out your consumer base until you've bled them dry. A few years back, I would have argued that that's their prerogative if they provide the better technical solutions to problems in graphics development. Today, I believe that they're marauding monopolists. They are too high, on their own supply, and they're ruining it for everybody. If nvidia had real generational improvements to sell, they wouldn't do it by selling us outright lies. And I hate they're getting away with it time and time again for over 7 years.